In this statistics lesson, we will be discussing hypothesis testing for the mean when we do not know the standard deviation of the population. Please take a moment to press pause and read through today's objectives. Now, as you read, we will need to use a t-distribution, just like when we did confidence intervals. Same thing. If we don't know the standard deviation of the population, we can use S, but we will also need to adjust and use a t-table, a t-distribution as well. So when you are working through these, make sure that you start by looking at your level of significance. You will need to look up the degrees of freedom on your chart and that level of significance. Decide whether it's one-tailed, two-tailed, and then use your table, which for us is table 5 in Appendix B, but you can look at your book, and that will tell you where it is in your textbook. You can look these up online as well. They're everywhere. All right, so let's just jump right in and talk about finding those critical values. So find the critical value, T sub C, for a left-tailed test, given that alpha equals 0.05 and that n equals 1. Okay, so we are doing a left tail only test, so left tail. And we want this area right here to be 0.05. So I would go to my chart. My degrees of freedom is going to be 20, right? Remember, it's just one less than the sample size. And I would go to the column that says one tail and has an alpha of 0.05. Go down that column until you get to 20 degrees of freedom, and whatever row and that column intersects that row, you should end up with a t critical value of negative 1.725. So make sure that you are practicing using that chart just like we did when we were doing confidence intervals before. All right, for the next example, same thing, but this time it's a right-tailed test. So my picture will look like this. It will be right-tailed. It's going to be 0.01 is my alpha, so that's the area right there. And I need to find the critical value that goes with that. So I would go to my chart. I would look for 16 degrees of freedom because my sample size is 17. I would look for one-tailed, right-tailed of 0.01. I would go down the chart, and this should be positive, again, because we're on the right side, 2.583. So again, you already know what your sign is going to be, positive or negative, based on what kind of tail you have, so that makes it a little bit easier. All right, and one more just to make sure. Find both critical values for a two-tailed test. So this time we're going to have a two-tailed test. So two-tailed test, our alpha is 0.10, which means each of these tails is going to be 0.05. So both of my tails are going to be 0.05. So I need to find my critical value that's negative, and I need to find my critical value that is positive. All right, so I would go to my chart. I would look up 25 degrees of freedom. I would look at two tails with an alpha of 0.10. I would go down that column, look at that row of 25 degrees of freedom, and you should get negative 1.708 and positive 1.708. One of each. All right, so make sure you practice with that chart so you can find those critical values before we get started. All right, so if you're going to do a hypothesis test for a unknown standard deviation for a mean, you're going to have to use a t-test. Notice it's almost identical to my z-test that I was doing before, but instead of sigma, you're going to use S. And again, we're doing t's. You're using a t-distribution this time. We still have to have a random sample, and we still either have to have a population that's normally distributed or an n greater than or equal to 30. So the same conditions apply in this as well as they did for the Z. Okay, again, here are the steps. So go ahead and press pause and write down any of these that you need to make some notes on, and we will go through all 9 of these steps together as we do some problems. All right, so a used car dealer says that the mean listing price of used vehicles sold in the last 12 months is at least. Okay, so here is their claim. They're claiming that the mean is at least. which means it is, again, be careful when you're doing the language, okay? At least means greater than or equal to, right? 23,500. That's the claim, and that's also going to be my null, right? Because it's got the equality in there. So that means my alternate is going to be that the mu is less than 23,500. All right, you suspect that this claim is incorrect and find that a random sample of 14 used vehicles, so n equals 14, which means my degrees of freedom is going to be 13, sold in the last 12 months has a mean price, so the sample mean is 21,558, and the sample standard deviation is 3,350. Right, is there enough evidence to reject the dealer's claim at alpha equals 0.05? All right, assume it's normally distributed. Okay, excellent. So we can proceed with our problem. All right, so look at your alternate. This is going to be a left tail, right? Because it's less than. So my picture is going to be a left tail only. I need that left tail to be 0.05. So I would go to my t-chart and I would look up that critical value. Okay, what is my critical value? So I'd go to the 13 degrees of freedom. I would go to one tail, 5%, go down the chart, and you should get a critical value of negative 1.771. Again, you know it's negative because it's a left tail. Okay, so that is my critical. Okay, now I have established my rejection region. So this is fabulous. So all I have to do is do the test T, and then find out if it falls in that rejection region or not. Just like we did with the Z's. So you're going to find that this is very similar. Okay, so my T test is going to be x bar minus mu over S divided by the square root of n. So very similar to the Z's that we were doing before. So x bar is 21,558 minus mu, which is 23,500, and that's divided by S, which is being divided by the square root of 14. All right, I'm going to put that on my calculator, and I get my test T to be approximately negative 2.169. I can go 3 decimal places because this is 3 decimal places. So notice that that will fall right there, right? It's going to fall in the rejection zone. So that means we are going to reject the null hypothesis. So we are going to reject the null. And so then you will need to write your conclusion in words. So if we're rejecting the null, which was the claim, so that's not good. Okay, so there is not enough evidence to reject the claim, right? So we're going to reject it. So there is enough evidence to reject the claim that the mean price of used cars sold in the last 12 months is at least $23,500. Right, so make sure that you are able to list the claim in words, so that way when you get to the end, you will be able to state your conclusion very clearly. All right, let's do one more with rejection regions. All right, an industrial company claims that the mean pH level of the water in the nearby river is 6.8. Okay, so that's their claim. So they are claiming that the mean of the pH water is 6.8. So that is definitely our null because it's got the equals. So that means our alternate is going to be mu is not equal to 6.8. So this is going to be a two-tail. Right, so let me draw my picture. So 2 tails are going to look like that. Okay, you randomly select 39 water samples. So n equals 39, which means my degrees of freedom will be 38. And I measure the pH of each. The sample mean and standard deviation. So that's a new one. So the mean is 6.7 and the standard deviation of my sample is 6.7. Oh, they told. Helps if I read the next sentence. My standard deviation is 0.35. There we go. I got too excited. Is there enough evidence to reject the company's claim at alpha equals 0.05? Okay, so if I've got 2 tails and an alpha of 0.05, that means each of these tails is 0.025. So that's the area in each of my tails. I can now look up those critical values, those T critical values. So this one's going to be positive and this one's going to be negative. So I would go to my T distribution chart and I would look up those critical values. All right, and when you look at the chart, you should get negative 2.024. So this one would be positive 2.024. Okay, so now we need to find our test t and see where it falls. Does it fall in the rejection zones here, or does it fall in the middle? So let's go find out. So our test t, again, is going to be x bar minus mu over s divided by the square root of n. So x bar, test t, I forgot the second t. X bar is 6.7, our mu is 6.8, divided by the standard deviation, divided by the square root of 39. So our test t is approximately, if I put that on my calculator, negative 1.784. And that is going to fall right there, right? It's going to be above negative 2.14. So that means we are in the do not reject. So we fail to reject our null hypothesis. Okay, so now I just need to put it in words. So I am failing to reject my null. So this has to be true. And that was the claim. So, well, I can't prove that it's wrong. I can't say that it's true. I can't say that I can prove it's wrong. So there is not enough evidence to reject the claim that the mean pH is 6.8. Okay, right now I can't say it's correct. I can just say I don't have enough evidence to say it's wrong. So there we go. There's some critical regions. You can also use p-value method with this as well. So let's try a couple of those so that we can walk through those examples as well. All right, so the Department of Motor Vehicles Office claims that the mean wait time is less than 14 minutes. So here's my claim. My claim is that the mean waiting time is less than 14 minutes. Okay, that's the alternate, right? Because it doesn't have an equal sign. So my null is going to be that mu is greater than or equal to 14 minutes. All right, this is going to be a one tail and it's going to be a left, right? Because if we look at the alternate, it's less than. So we're going to go here. We're going to do a left tail because it's less than. Okay, so there's my picture and that will be my critical value right there. Oh, we are not going to, because we're doing the p method this time. Hold on, back up. Okay, so don't get too far ahead of myself. Okay, random sample of 10 people, so n equals 10, which means our degrees of freedom will be 9. Has a mean wait time, so the sample mean is 13, and a sampled standard deviation of 3.5. And at alpha equals 10. Alpha equals 0.10. Test the office's claim and assume that we have a normal, where our population is normally distributed. Excellent. Okay, so we are going to use our test statistic. So this is going to be our test t, and we're going to use that to find our p-value, which will be right here. All right, so let's find our test statistic. So that would be our test t is going to be, again, x bar minus mu over standard deviation divided by the square root of n. So x bar is 13 minus mu, which is 14, over 3.5 divided by the square root of 10. So I'm going to put all that in my calculator, and I get that my test t is about negative 0.9035. Glad it came out negative, so I know it's the right spot. So this is negative 0.9035. Now, this is where it gets interesting when you're working with a p-value method on this. If I go to my chart, I have to look on the inside of my chart, right, to find when that value is going to be negative 0.9035. So I'm going to go to the 9 degrees of freedom, and I'm going to look across. And I see that the lowest t value that's on there is 1.383. And that says for a one-tail test, it should be 0.10. So it's much smaller than that, which means that my tail should have a area that's larger than 0.10. In fact, if you use technology to find that p-value, it turns out that p-value is 0.1949. But from the chart, all I can tell you is that that p-value is much greater than 1.0. So that's all I can tell you from the chart. So when you do these p-values, technology is really a little bit more important here. You really need to be able to get the technology on your side. But you can make at least you can know that your p-value is going to be greater than 1.0. based on the values in the chart for those degrees of freedom. All right, so our p-value is greater. So my p-value, which I know is greater than 0.10, you're going to compare that to your alpha, which is 0.10. So that means your p-value must be larger than 0.10. It's either greater than or equal to. So if the p-value is greater than, then that means we are going to fail to reject. So we're going to fail to reject the null. All right, so when I write it in words, I'm failing to reject the null, right? I can't say this is wrong, so that doesn't help my claim, right? So that's not good news for my claim. So there is not enough evidence to support the claim that the mean wait time is less than 14, unfortunately. Right? I can't reject that null. So that means my claim, I don't have enough evidence to support my claim at all. All right, so let's do another one of these p-values because these can be a little interesting. Oh, I didn't have another one planned, but I did want to show you technology. So here I have the TI-84 Plus all pulled up, and it'll tell you the p-value both on the screen and in the graph if you pull that up. If you use StatCrunch, same thing, it will just tell you the p-value outright. So don't be afraid to use that technology to check your work, but I really didn't need it because I already knew the p-value was greater than 0.10. So hope that helps with means. The only thing we have left to discuss is doing these hypothesis testing with proportions. So come back next time and we will talk about hypothesis testing with proportions.